Hi, I'm Dr. Philip Macmillan, and thank you for joining me today as I continue my exploration of research into not just COVID 19, but the implications of the pandemic. And I look objectively at all sides of COVID 19, so not just the infection, which contributes spike protein and can cause autoimmunity based on our initial research, but also the spike protein that exists with regards to vaccination. What impact can that have in the context of long term disease? It's very important when we look at science that we ensure that we're always objective in what we are doing. And so, what I'm looking at today is a heart failure epidemic. And heart failure is just simply the fact that the heart is not able to efficiently pump blood around the body. Now, this is usually something that comes with very characteristic symptoms: shortness of breath, swollen legs, limited exercise tolerance. And these are characteristics that we see in patients with heart failure. And we can oftentimes manage it from the perspective of using things like diuretics, medication to reduce the blood pressure, medication to increase or slow down the heart. So there are many things we can do with heart failure, but I think that we're coming into a very important transition in the pandemic. And what I'm trying to demonstrate here is that we are likely to be seeing far more complicated heart failure in the future. I've gotten this very interesting image that was done by someone on Twitter. I've put his link in the description, called OS. And he's just somebody who likes to analyze data. And it's very helpful when somebody puts together data in a way that can make sense. And what he has done here is that he has taken this period, let me just make it full screen, from 2015, you may not be able to see it, to 2019, created this baseline of zero excess mortality. And what you can see here is that this dotted line here represents the COVID cases. So this is the first wave of the pandemic, and all of this data comes from the UK. And so you can see that there was some element of increased heart failure above the baseline in 2019, but then you had a spike in relation to the pandemic. It then came back down, and then it went up again, and then it came down, and then it has continued to rise. And if you move across to the peak here, this is over 60% increase in excess mortality. And this is all the way to the end of 2022. And again, it has come down here, but one would expect beyond this that it was bounce up again. And this trajectory seems to be rising consistently. What he has done as well is he's colored yellow, meaning the first dose of vaccination, green, meaning the second dose, red, meaning the first booster dose, purple means the fourth dose, and this light blue represents the fifth dose. So, a very interesting breakdown of the data. And before I show you what I think is happening here, I want to give you some basic understanding about the heart. And so I've got here an image of the heart, and it's cut through the middle. And what you can see is that you have two sides to the heart separated by this very big muscular septum, we call it. So this is the right heart. And what happens is blood comes in from the veins, and it is then pumped from this right ventricle through the pulmonary valve into the lungs. And this is where the blood gets oxygen. It then comes back through the pulmonary vein into the left side of the heart, where it is then pumped around the body. Comes in through this mitral valve and then is pumped out through the aortic valve, which you can't quite see here. And so the importance of that is that you have two sides of the heart, the right side and the left side. And very often when we talk about heart failure, we're talking about left-sided heart failure. That means that the heart isn't pumping very well. There's a backup of pressure in the lungs, and then that leads to right-sided heart failure. That's what we call congestive cardiac failure. And so this is just an image here of the heart in the middle with the lungs. So just remember the right side pumps the blood through the lungs. It then comes back to the left side of the heart and it's then pumped around the body. So we'll come back to that in a little bit, but it's important to understand those basics with regards to heart failure. When it comes to understanding what is the cause of this excess mortality around heart failure, this is where I then go back to my basics of research, which is around autoimmunity. That's what I've been focused on from the start of the pandemic. Essentially, all we said in our research was that the spike protein here, which is part of the virus, each viral particle has multiple spike proteins. We just said what happens if free ACE2 binds to it and then it gets picked up by the immune system. The immune system will think that this ACE2 is part of the spike protein and make autoantibodies to it. And this is exactly what was found in the research, that there are autoantibodies to ACE2. And I've always said that, therefore, severe COVID 19 is an autoimmune disease triggered by the SARS-CoV-2 virus. Now, just to make it clear, many people don't agree with that. They recognize that there are autoantibodies to ACE2, but they don't necessarily think that those autoantibodies are relevant in the context of being the primary cause of disease in severe COVID 19. So that's just where the scientific viewpoints differ. I'm holding my ground on this because everything that I have seen in the pandemic can be explained by autoimmunity. So, taking it further, just remember the simple point. I have said that we're going to end up with autoantibodies to ACE2. Guess where they are concentrated? They are concentrated in the lungs, especially the blood vessels in the lungs. And when we make this full screen, you can see here these little sacs of alveoli where the air comes in and then it exchanges oxygen and carbon dioxide. And then this is how the blood gets oxygen and how it releases carbon dioxide. But there are some arteries coming to these alveoli and they have high levels of ACE2 in them. And so, therefore, in the context of both severe COVID 19 and what I predict with regards to immunity, autoimmunity ongoing beyond that, you could have blockage of these little vessels, which will then increase the pressure on the right side of the heart. Remember, the blood has to come through the right side, go through this pulmonary artery through the lungs. So if the pressure increases in this, you will then have what we call right-sided heart failure. The oxygen can't get to the blood, and enough blood can't get through the lungs to get to the left side. And that's essentially what I think is going to be happening in the context of heart failure. So if we go back to this image that had all the data on it, and you can see here these spikes. Now, it makes perfect sense that you would have a spike around severe COVID 19 because it targets people who have heart failure as well. And so you would expect that those people would have died. It drops back down to the baseline. And then some people would have had severe damage to their lungs and probably the blood vessels. And you have then a second spike that occurs a little bit later on. But here we move into the area of the vaccination. Now, remember the principle. I've just said quite simply, if ACE2 binds to the viral spike protein, is it possible that it binds to the vaccine spike protein? Now, it does, because this is how we knew that the vaccine spike protein was the correct formulation and shape, because it bound to free ACE2 in the tests. So absolutely it does. Is it possible that you can get an autoimmune response? Based on my research and extrapolation, I would think so. So let's get back to the image. And therefore, this is now the same image that I've concentrated down to the pandemic period. And what you can see here is that once you hit these two periods where you have the first and the second dose, heart failure does seem to rise. It comes down a bit and then it continues to rise again after the third dose. Now, some people may say this is purely coincidental. It may be. I can't say for absolute certainty that this is relevant. But in the context of science, what you don't do is discount an observation. You need to make sure that it is not directly relevant. And based on what I said about autoimmunity, if this occurs in a small proportion of patients, you have to remember that we're dealing with small numbers of patients that causes significant rises in excess mortality. What I find happens is as soon as you talk about this, everyone imagines that it's their problem. No, when you look at a population of 1 million people, even small percentages make a big difference to the pressure on hospital systems, excess deaths. And that's how this fits in. It's very, very important for us to look at these things and to try and understand them and acknowledge them if they are relevant. Because if we don't, the outcomes of that could be disastrous. Remember, this here is the pulmonary artery. What I essentially am saying is that the pressure in this pulmonary artery, because of this autoimmune process, which can occur either because of infection or potentially because of vaccination, you can then end up with higher pressures here, leading to right sided heart failure. That's the bit that I want us to look at from a research point of view. Prove that point. Let's check and see. The difficulty with right sided heart failure is because it's very difficult to treat. Left sided failure and congestive cardiac failure, we have lots of drugs that we can use to help to manage it. But right sided heart failure, secondary to pulmonary hypertension, is extremely difficult to manage. And that's why it's so important for us to therefore understand exactly what could be occurring. As usual, I'm trying to challenge the science here. I can't say for certain that this is occurring, but this is certainly what I would expect based on my research around ACE2 autoimmunity. If you want to keep up to date with it, please remember, join me on Substack. And I hope you found this valuable and something that we can push forward to try and get some clarification on to see if this is correct. Have a good evening.